All right, this is lesson 23, page 108, graphical solutions. All right, so the way that this lesson is in the textbook is not the way that I want you to work it, which is a lot of the times, right? This lesson is taught in the textbook to graph the equations and find that point of concurrency where the two lines intersect, and then confirm that point that you found by using substitution or elimination. Okay, that's not the way I want you to work. I do want you to graph them, and then I want you to 100% of the time we're going to use substitution. We're never going to use elimination. All right, so to graph these, you're going to begin by putting them in y equals mx plus b format, slope, intercept format. All right, so we have 3y minus 2x equals 6, and we have y plus x is negative 1. All right, so I add the 2x on both sides. I'm left with 3y is 2x plus 6. Then I divide by 3, every term by 3. So I'm left with y is 2/3 x plus 2. All right, that's one equation. The other equation, I'm going to subtract x from both sides, and I'm left with y is negative x minus 1. All right, so I will begin with graphing them. Now, what values will I choose to plug in for x in this equation? 3. Yes, we want to eliminate that denominator. So 3, 0, and negative 3. All right, when x is 3, Brianna, what is y? What is 2/3 times 3?
6/3.
6/3 or 2. 2 plus 2 is 4. When it's 0, what's y, Madison?
2.
2. And when it's negative 3, what is y? Anybody?
0.
0. All right, I'm expecting a positive slope, so when I graph it, I should have a positive slope. And remembering to label part of your graph, 1, 2, 3, 4. And I have 0, 2. And then I have negative 3, 0. Expecting a positive slope, which is what I end up with. All right, so that's the first equation. We're going to graph both of these on the same coordinate system. For this equation, y equals negative x minus 1, I am going to just choose easy numbers. 1, 0, negative 1. 1, 0, negative 1. When I plug in 1 for x, the opposite of 1 is negative 1. Negative 1 minus 1 is negative 2. Always when I plug in 0, I get the y-intercept, so that's negative 1. Now this one, when I plug in the negative 1, the opposite of negative 1 is positive 1. So 1 minus 1 is 0. So I have 1, negative 2, and I am expecting a negative slope, so I should make sure that my line is falling. 0, negative 0, negative 1, and negative 1, 0. All right, now I could guess, what that point of concurrency is, but without it being on graph paper, I could guess it's negative 2, 1, but that's not what we're going to do. We're going to always use substitution. We're going to graph them and use substitution. And then confirm that our numbers are in fact very close. All right, both of these equations are set equal to y, right? Y equals, y equals. I'm going to substitute that in for y. So I will have 2/3 x plus 2 equals negative x minus 1. I'm always going to set them equal to each other. All right, now, I have an equal sign. Equal sign means I eliminate the denominator. So I'm going to multiply every term by 3 to eliminate the denominator. So I'm left with 2x plus 6 equals negative 3x minus 3. I don't want to move all my x's to one side, my like terms, and my constants on the other side. So I'm going to add 3x to both sides. And I'll subtract my 6 on both sides. So then I'm left with 5x equals negative 9. Dividing by 5 on both sides, x is negative 9/5. Well, that's close to negative 2, but that would even if I were graphing on graphing paper, I really don't think I could figure out negative 9/5, right? It'd be hard. All right, so now once I have one value, I'm going to plug it into one of my original equations. Actually, I'm going to plug, that one's the easiest one. And we'll solve for y. So now y equals the opposite of negative 9/5 minus 1. Opposite of a negative is a positive, 9/5. And I'm going to make this 1 5 over 5. So that we have a common denominator. 5 over 5. So y is 4/5. Now I have my coordinate point here is negative 9/5, comma, 4/5. That is that point of concurrency. That's where they're consistent. When we're looking at systems of equations, that would be the point of consistency. In geometry, we call that the lines are concurrent at that point. All right, so look at example 2. All right, so example 2 says y minus 2x equals 2 and y equals negative 3. For this equation, I add the 2x on both sides, and I'm left with y equals 2x plus 2. All right, now I have the two equations. What is the slope of this equation? 0. Is it a horizontal or vertical line? Horizontal or vertical line? You remember? Horizontal, yes. All right, so we can go ahead and graph that. Negative 3. And I know that if this line intersects it, where it intersects it at is going to be at y equals negative 3. So I already know my y coordinate of the point of where they're going to intersect. All right, so let's plug in numbers for x. We'll do them easy. 1, 0, negative 1. And we'll solve for y. So 1 times 2 is 2. Plus 2 is 4. So we have 1, 4. When x is 0, y is 2. When x is negative 1, that makes this portion of the equation negative 2. So we end up with 0. And plotting that, reminding myself I am expecting a positive slope. I'm expecting it to rise. This is 2, 0, 2, negative 1, 0. So that's my point where they are consistent. I know my negative value, my y value is negative 3. I know that. It has to be. If I had an x equal equation, I would know my x value, right? All right. Now, to solve for x, I'm just going to plug -3 in for y and solve for x. So I have -3 equals 2x plus 2. Just plugging in that value for y and solving for x. Subtracting 2 on both sides, I'm left with 2x is -5. And then when I divide both sides by 2, eliminating the 2 on the right hand side, x is -5 halves. It is in the negative range, so my answer is logical. So that's really the only reason why we're graphing them, as well as finding the point where they intersect, to show you they're consistent at that point, and to eyeball it and say, is that logical? Because if I had gotten -5 halves and 3, and maybe instead I had drawn this line as a positive slope incorrectly, then they would have maybe intersected over here, and I would have gotten the wrong x value, so I should have said, there's something wrong with my line. Okay? Work the practice problem on page 110.